write a problem. Question is, if cos alpha, cos beta and cos gamma are the DCS, it means direction cosines. DCS what? Direction cosines of a line, okay, of a directed line, then prove that cos² plus cos²β plus cos²γ equals to 1. And to prove this question, you should know the knowledge of projection vector. What is projection vector? So before proving, let me again revise what are projection vector. Projection of vector A on vector B. See, projection means simply shadow of a vector. Suppose this is one vector and this is another vector. This is another vector. Okay? And this is A vector and this is B vector. Okay? This is A vector, this is B vector. Then what is the projection of A vector on B vector? A vector is here. So projection of A vector on B vector is nothing, it will be the shadow. You have to draw perpendicular from here. O, suppose this is capital A and capital B. So this OB length is called scalar projection. What? Scalar projection, OB. OB will be given by mod A and cos theta, where theta is what? Theta is the angle between A vector and B vector. What is theta? This is very important. Theta is angle between A vector and B vector. Okay, and you know already what is the formula for cos theta? Cos theta is A dot B. Cos theta was, if theta is the angle between A vector and B vector, then what is cos theta? A dot B upon mod A mod B. Yes. So here, and this is OB is called what? Scalar projection. OB means scalar projection, because projection of two types. One is scalar projection and one is vector projection. Scalar projection means only magnitude. Okay. Scalar projection will be mod A and cos theta. Okay. Mod A cos theta. Note this, projection of A vector on B vector. We know that cos theta is A vector dot B vector upon mod B and mod A. Correct? So put this value here, cos theta, then what is the final answer? Tell me. Put cos theta here, then mod A cancel, so answer will be A dot B upon mod B, and this formula I given last time. Projection of A vector on B vector. Then scalar projection equals to mod A and A dot B upon mod A and mod B. So mod A cancel. So answer is what? Mod A dot B upon mod B. This is scalar projection. This is scalar projection. What is vector projection? Vector projection. Then vector projection. Vector projection simply means the projection vector of vector A on vector B. A vector projection will be scalar projection, okay, multiply by unit vector of B, unit vector of B vector, because we are finding projection of A vector on B vector. So what is vector projection? It will be scalar projection means this value into unit vector, okay, unit vector of V vector. And how to denote unit vector? Cap vector. It means scalar projection value is A dot B upon mod B, okay, mod B bracket, and unit vector means B cap. This is the vector projection, because A dot B is scalar quantity, mod B is scalar quantity, so this is scalar and this is vector, so this is vector projection. Scalar projection A dot B upon mod B, and vector projection A dot B upon mod B, B cap, okay. And do you know what is B cap means? B cap means vector B upon mod B, correct now? So if I put this value here, then we will have two forms vector projection. Then vector projection will be A vector dot B vector upon magnitude B, and B cap answer is B vector upon magnitude B, and magnitude B and B twice, so whole square. It implies okay, this. So you have to remember two forms. One is this and one is this. Directly questions comes like this. Okay, in word 3 directly they ask what is a projection vector of A vector on B vector. Sometimes they will ask only scalar projection. You have to differentiate which one they have asked. Only scalar projection or projection vector. If term is only mentioned, find the projection itself is scalar projection. If they ask find a vector projection on other vector, then A dot B upon mod B square B cap, B vector, okay. Now can projection be negative? Projection, can it be negative? Tell me the question. I said projection means shadow, okay, it is like shadow, and you will think shadow means length, and length is not negative. But in vector, scalar projection can be negative. Don't know why? Because what is the scalar projection? Basic formula. Scalar projection, if you remember, it is mod A cos theta. Mod A is the length, and cos theta may be negative, may be positive, and may be 0. Suppose if theta is obtuse angle means more than 90 degree, then cos theta always negative answer. Cos theta always negative answer. If theta is acute, then less than 90 means suppose cos 60 1 by 2. That time scalar projection positive, and scalar projection 0 also possible. If theta is 90, then scalar projection 0. If scalar projection 0, it means there is no shadow. It means both the vectors are perpendicular. Next point. Scalar projection you can write as a remark. Okay. Scalar projection means this. Here again I will show the figure. This A vector, V vector, and here this, okay, A vector, and this is B vector. This is O, A, and B. What is OB? Okay, OB means scalar projection, and scalar projection means mod A and cos theta. Now whenever theta varies, okay, your scalar projection varies. Positive maybe negative, and maybe 0. So first one, if theta is acute, that is theta greater or equal to 0 and less than 90, then cos theta is positive, and hence scalar projection is positive. scalar projection is positive. Number 2, if theta 90, then cos 90 0, then cos theta means cos 90 and means 0. It implies OB 0 and OB 0 means then both the vectors are perpendicular. So what is the meaning here? A vector perpendicular to B vector. Hence vector A and B are perpendicular vectors. Vector A and vector B are perpendicular vectors. Number 3, if theta is obtuse, it implies theta greater than 90 and less or equals to 180. Then cos theta is negative and hence scalar projection is negative. Then projection. Can projection of a vector be negative? Answer is what? Now what is your answer? Yes, absolutely. Yes. Yes, absolutely. Absolutely. It's surprise. It is surprising you. It's surprise. Okay, students. It surprised students that projection means like vector length and length. How can be negative? Okay, then you write your answer. So when you read this statement, you will recall the class. So scalar projection negative it simply means that the direction of the projection vector is just opposite. Okay, it surprised students that scalar projection like shadow, okay, length, and they are positive. But when scalar projection is negative, it simply means that the vector is pointing in the opposite direction, means that the vector is pointing in the opposite direction of a directed line. Opposite direction of a directed line. Then now I will solve a beautiful problem which is also present in your question bank. Okay, and when you see that problem, you will feel some fear, but after applying all the concept, that problem will be very easy to you. Noted? Can I erase? Question. Okay, I will draw one figure and then I will ask you something. Okay, just pay attention. Look here, and I'm joining this to this, this to this, and then I'm saying this is O vector, this is A vector, this is B vector, and this is, suppose, no, this is A vector, and this is B vector, this is C vector. Okay, and this is L, this is M. So what is the given information in figure? In figure, suppose I am saying OA vector means small a vector, okay, and I am saying OB vector, small b vector. OC vector is small c vector. BC vector, let's say x vector, okay. Then find LM, okay. Then find LM, and options are there. Options. A option. Let me write option from the book. A dot C upon mod A. B option. Option B. A dot B upon mod B. A dot B upon mod A. Option C. A dot B plus C and upon mod A. Option number D. C minus B dot A upon mod A. Solve this question. Once you give a think how to solve this problem. It's a very, very, very good question. One of the good problem in the vector algebra. You need LM, students. What is LM length? LM means from this to this, correct? This is your LM. Okay. Question noted. Now look here. Explanation. Stop writing. See, you want LM, correct? And how to get LM? If you know OM distance, OM minus OL, you know from O to M and O to L. So if you delete OL from OM, you will get LM exactly, correct? And what is OM? OM is what? If you observe this vector and this is perpendicular, what is OM? OM is nothing, it is the scalar projection of vector OC on OA, correct? And what is OB? How to get this vector, this length OL? This is the scalar projection of OB vector on OA vector. So we can get now, we have the formula, then we can get the answer. So you will observe that LM means it is OM minus OL, and OM means scalar projection of a scalar projection of C vector, because what is OC vector? OC vector is C, no? This is C vector, and this is B vector, and this is A vector, correct? A scalar projection of C vector on A vector, because OA is what? Small a vector. Then what is the formula? C vector projection on A vector, C dot A upon mod A. So it will be C vector dot A vector upon mod A. Okay. Then what is OL, students? See, OL is scalar projection of B vector on A vector, correct? Scalar projection of B vector on A vector. Then what is this? B dot A upon, it is B dot A upon mod A. Now put this value in equation 1. Suppose it is first equation, it is second equation, it is third equation. Put the values of equation 2 and equation 3 in equation 1. Then from 1, what is LM? LM means OM, and OM means C dot A divided by mod A minus B dot A, correct? B dot A upon mod A. Denominator same, so mod A, and it is C dot A minus B dot A. Now dot A is common because dot A right hand side, dot A is a commutative property, so we can take dot A common. Then it is C vector minus B vector divided by mod A and dot A vector. Now you can see which option is correct. D option is correct. Okay, very good question. One of the good problem, okay, in your NCERT book. That's why that geometrical knowledge is required to solve such kind of problems. Now I will make one figure here. I need this. Okay, can you do this? I'm making a box. Then join this to this, this to this, this, and this. After that, extend this, and this. So, and call this is x-axis, this is y-axis, this is z-axis, and this is origin. Okay, and I extended this line, this line, this line. This is my x-axis, this is my y-axis, and this is my z-axis. Okay, now suppose I am taking a point P in the space. It's a 3D diagram. Suppose this is point P. This is what? Point P. And what are the general coordinate of point P? X, y, and z. So if I join O to P, this is origin. If I join O to P, then what is this? O to P. This is OP vector. OP vector means small r vector. We call now this vector is small r vector. Small r vector. Then what are the coordinate of small r vector? Position vector of point P. R vector, we write x I cap plus z k cap. Now here is the required thing. Point P in the space. Point P in the space. Then what is the meaning of x, y, and z? X, y, and z. X means you are going for x steps along the x-axis, and then y steps along y-axis, and then z step along z height. Then you are reaching here. This is x step, and I am writing x I cap because I cap means unit. I cap is what? 1 unit, no? I cap is a unit vector. So first x I cap, and then I will ask to explain this. Wait. This is y j cap, and then this is what? Z k cap. And what is xi? Xi is nothing. It is a projection of OP vector, means r vector on the x-axis. If you join this to this, any other color, suppose this. If you join this to this, can you think this is 90-degree angle? This angle is 90 degree. Can't see because it's a 2D, 2D plane, but I am showing the 3D things. And one more thing, when you join that space point, when you join to that, it will draw a perpendicular. So actually, whatever this triangle like this is your x-axis. This is your x-axis, and this is radius vector, r vector, and here this is point P. So whenever this point P, you will match this, it will come like this here. Now can you see it is 90 degree? 90 degree, yes or no? This is r vector, this is x-axis. And suppose this r vector making alpha angle. Remember direction cosines. R vector making alpha angle with the x-axis, beta angle with the y-axis, and gamma angle with the z-axis. So if this r vector making alpha angle with the x-axis, then what is this? This O, let's suppose OM, sir, OM. OM is nothing, it is again projection of r vector on x-axis. Projection of r vector on x-axis. How to give projection? Length of this, what is the length of this? Mod r. It means mod r and cos alpha. What is OM? OM is what? Mod r cos alpha, and OM means x steps. It means OM is what? X is what? R mod cos alpha. This is the projection of what is small x? Small x is nothing. It is the projection of r vector on x-axis. It means this value is nothing. It is projection of r vector on x-axis. Similarly, what is this? Projection of r vector on y-axis. Projection of r vector on y-axis. And what is z? Projection of r vector on z-axis. And what is the value? X value means mod r cos alpha. X value means mod r cos alpha. And what is y? Mod r cos beta, then I cap and j cap. And what is this? Mod r cos gamma k cap. Can you see mod r common? Mod r common. So it is what? R vector and mod r common. And mod r common come here, upon. Then what is this? Cos alpha I cap cos beta j cap plus cos gamma k cap. Now what is this? Any vector upon mod unit vector. Correct no? Any vector upon mod r unit vector, it is r cap. R cap means cos alpha I plus cos beta j plus cos gamma k. So if I apply mod on both sides, mod of this and mod of this, because it is cap vector, cap means unit vector means length 1. So this is 1 and this is what? Root over cos² alpha plus cos² beta plus cos² gamma. Squaring on both sides. What you will get? Cos² alpha plus cos² beta plus cos² gamma equals to 1. That's why everyone is saying cos² alpha plus cos² beta plus cos² gamma equals to 1. So this is the proof. Okay.